Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. So today we've got Ben who has just completed the course ROS 2 Navigation, and he will be giving us a presentation on how he has managed to complete the project. So as usual, we'll first begin by seeing a demonstration of his code base running on a real robot, and then after that we'll get into some details about how he managed to do his project, and then towards the end we'll get to ask him a couple of questions. So I will now hand over the time to him so he can begin his presentation. Alright, Ben, whenever you're ready.
Okay. Hi, everyone. So I still have not too long, about 20 seconds until I can log into the robot. But what I'm basically going to be showing you in order is the project mapping, the map that I built. And secondly, I'm going to be going over the localization process that's in the project localization package right here.
Mm-hmm.
And then I'm going to talk about the navigation portion of this project, which is handled within the project path planning. And within that, I made my own custom interface. So let me log into the robot. And once I'm logged in, then I'll log into I'll use the teleop keyboard to do manual navigation, just to make sure that everything is working properly.
Okay.
Okay. Can everybody see that the robot is logged in right now?
Yes, we can see that.
Okay, perfect. All right, let me get to teleop keyboard real fast. Click, so seems to be working when I manually drive it. That's exactly what we want.
Mm-hmm.
So just for simplicity purposes and for the sake of the demo, I'm going to kind of put the robot typically where you would see it starting off in the simulation, which is around, I guess, right here.
Mm-hmm.
So now what I'm going to do is I'm going to begin demonstrating the localization portion of this project. So what I have right here, I have everything pre-saved, just so I don't make any typos or anything like that. I'm typing it all out. But once I source my workspace and everything, it'll launch all of the necessary nodes, and it should launch RViz as well. I have that internally added as a node. So you can see that right here.
Yes.
So here, I have my configuration. Let me open that real fast. All right. So here's the map that I generated. One thing I will say is that I did generate this map using the simulated environment rather than the real environment. But I do have a reasoning behind this, and I'll kind of go more into that and explain it when I talk about the mapping section.
Okay.
I just want to let you know that that was by design.
Yeah. It looks pretty perfect.
Yeah, and so as you can see, when I do the 2D pose estimate, there is a little bit of offset.
Yes.
But as you can see, like once I start moving the robot around, so you'll begin to see with the particle cloud. Let me try and minimize. There we go. Yeah, so once I start moving around manually,
Mm-hmm.
You'll be able to see that the robot, it will become more familiarized with its environment. So
Okay.
I'm just going to do kind of one lap around the track.
All right.
It's kind of hard to see with this. Let me reduce this window. There we go. Okay. So as you can kind of see, just as I'm going around the map, you can see that in the real screen, there is that obstacle that's right there.
Yes.
So that was partially one of the reasons why I decided to use the simulated map to build this.
Okay.
Was because I noticed that, when every time other users are kind of logging in, the map kind of changes over time. It's never really consistent.
Yes.
So
Because of the movable obstacles, right? Yeah.
Exactly. Yeah. So I found that, you know, in the simulated environment where things are kind of static, it's I think it provides more consistency with that.
Yeah.
So
Yeah. Yeah, well,
so moving back.
yeah, it does come with its own perks, right? Sometimes it might not be as accurate, but I quite like the way it's working so far. So when you were moving it right now, you're just trying to localize it. You were not creating a map, right?
Yes, exactly. The map is already generated in static.
Okay.
That was loaded in.
Okay.
What I
Okay.
was doing right now, though, was you probably noticed beforehand the particle clouds around the robot were scattered all around.
Yes.
But as I just did one lap, again, it's not exactly perfect yet, but the particles did begin to condense
Yes. Yes.
around the robot, meaning that it is becoming more familiar with its environment. So
True.
um, that's the localization kind of demo, like right there.
Mm-hmm.
And now I'm gonna go on to path planning. Let me show you exactly
All
what that's
right.
going to entail. So let me launch that that launch file. Okay, and so yeah, lifecycle manager, BT navigator. Okay, things seem to be launching as expected. So here's what I'm going to do. Um, with this, with the tool that's provided here, 2D goal, 2D goal pose,
Mm-hmm.
I'll be able to manually uh, kind of communicate with the robot and tell it where to go throughout the
Mm-hmm.
map. So
Yes.
if I do 2D goal pose, like for example, like if I just go down here and I guess, yeah, if I just wanted to go down here, you'll notice that in RViz and in the real-time screen that the robot seems to be following that pretty well.
Yep.
Again, there is that obstacle that's in the way right there. So there can be some inconsistencies, I guess.
Yeah.
Uh,
Did it touch it? Did it manage to avoid it, or it just stopped? Oh, it okay. It moved it actually. Okay, so it did manage to avoid it.
yeah. Okay, so right there, it kind of collided with the wall a little bit, I guess, with the way that I put the 2D goal pose. So
Yeah.
here, let me kind of have it go back a little bit.
Yeah. And also, I think it's also because of where it thinks the map is actually. It's the way it's localized also kind of affects it a little bit.
Yes, exactly. Here, it's kind of hugging the wall at that point. That was kind of a weird path that I gave it just now, but here, let me go back to RViz.
All
So
right.
if I do the 2D goal pose and I have it move in this direction, for example,
Uh-huh.
you'll see that it follows the path. I'll even have it go, and in the in the screen right here, it'll say, you know, go to the goal was succeeded.
Okay.
Okay, so let me continue doing it. I'll have it go kind of where it was and have it turn around
All
completely.
right.
So as you can see, it's going, and it should turn around exactly.
Okay. Okay. I see. Get
All
the
right,
proper
pretty
orientation. Yeah.
yeah, proper orientation, pretty decent. So the next thing I'll kind of talk about to show that navigation is continuing to work is there was a portion of the project called save spots
Mm-hmm.
where you're basically in the project, you're instructed to go to different spots around the map.
Mm-hmm.
To be specific, you know, they're defined as corner one, corner two, and the pedestrian one. So corner one is kind of, if you can see on my screen where this obstacle is, it's about right there.
Mm-hmm.
Um, corner two would be right here in the back
Yeah.
on the opposite side of the map. And the robot's kind of standing pretty close to where the pedestrian the third spot would be. So in order to make this happen, the first thing that has to be done is the spots have to be saved after the robot manually, so I'm going to manually navigate to those three individual spots
Yes.
and save them. So here, let me go to well, first, let me launch that. So the first thing that has to be the service itself, the spots to file, it has to be launched.
Mm-hmm.
And it should successfully launch, meaning it's ready and available and waiting for spots to be saved. So as you can see, it says the service is ready. It's ready for spots that are incoming to be saved. So here, I'll kind of move, as I'm manually navigating, I'll kind of move this obstacle. It's kind of blocking me.
You gotta make sure it's
Okay,
really in corner one.
yeah, I just don't want to have anything potentially interfere.
All right.
So, all right. So I'll put it right, let's just say right here. All right. So now what I'm going to do is, since the service for the spots to file has been called, I just have to basically use this command right here. And what it'll do is it'll define where the robot is currently standing on the map as corner 1. So as you can see, the response that was given, success is true. So this spot is defined as corner 1, okay, which is good, exactly what we want. Now I'm going to go and move to corner 2, which is, like I mentioned, on the other side of the map. Go do that real fast. Okay, about right there. And just to be safe, I'll have it turned this way. All right. And so now that it's in corner 2 is what it's going to be defined as. I'm going to basically redefine this position. All right, perfect. Success is true. Managed to save the spot to the corner. All right, and then we'll go to the last spot. And that'll be in the pedestrian one. Oh, sorry. All right, and I'll have that key right there. Okay. So now, for the last one, this will be defined as pedestrian. All right, perfect. And so it was saved as true. So now that all the spots are defined, and keep in mind, this is strictly for demonstration purposes.
Yep.
In order to have these saved spots correctly written, like basically saved and written to the spots YAML file, I would have to call out this. I would have to call out this to basically write these saved spots to the YAML file to be extracted. But just because I have these kind of values and these coordinates hard-coded, and I don't want to mess up anything at this point, just know that I would have to call this, go into the YAML file, extract the coordinates, put it in, and then rebuild the package to ensure. But as you can see, these would be saved. Remember that I just have to. I would have to do that.
Right. You'd have to do the same thing with the with the map also, right? So if you had the time, you'd need to build it with the actual environment, right?
Yes, exactly.
Yeah. Okay. All right. I understand.
Yes. So once that would be all done, now it's a matter of simply calling to the robot, calling it to go to the defined positions that we gave. Right. So right here, I'm going to call for it to go to corner 1. Okay. Let's see how it goes. Okay, so sending the robot to the corner. The goal was accepted. I'm glad I moved that obstacle. And yes, yeah, and there it goes. It goes right there. Right. So, yeah, and as you can see, like it is a little bit of offset in Arvis still, but not, not anything crazy. Yeah. Here, I'll go to corner 2 now, which is on the other side of the map. Hopefully it's okay. Okay, so goal was accepted. It's navigating there right now, going through.
Okay, does it one?
It took one obstacle with it. It took one with it. I think that's, yeah, like I mentioned, that was kind of an issue with, that's one of the downsides of having a static map,
Yeah.
um, I would say. But again, I'll delve more into that and the reasoning mainly why I did that.
Yeah.
I already kind of talked about it a little bit,
Yeah.
but
It's also supposed to be able to avoid, right? But I think the obstacles have got something to do with the geometry that makes it difficult for the robots to at least,
yes,
yeah.
yeah, and there are workarounds behind it. Like I could have incorporated kind of a PID controller methods for this, but that was that's something I didn't do for this project. I was mainly trying to focus on this. So
You
here, let me,
you mean a PID controller for obstacle avoidance? Oh,
or there are alternative methods, is what I'm saying,
right. Okay, I see.
besides using a static map like this for obstacle avoidance.
All right, so that you can be able to deal with the dynamic situation better.
Yes, exactly. Yeah,
Okay, I
this
see.
is just what I use. So now to go to the last spot, pedestrian. Let's see. Okay, and it stops right there, and it says goal accepted.
All
Perfect.
right,
Yeah,
that's perfect.
yeah, and so yeah, here's the output from RViz as well, and so yeah, that was basically you can see that the spots would successfully been saved. They'll go to their predefined positions that I defined, and so yeah.
All right, all right. Very nice presentation, Ben. I like the explanations, the details as well. So that's very nice. Um, okay, so on a couple of questions.
Oh wait, no, I'm sorry. I have a whole PowerPoint presentation I would like to give too.
Okay, let's go for it.
Yeah, yeah. Sorry about that. Yeah.
It's all
Um,
right.
so yeah, I'll be kind of going back and forth between these to kind of show some of the programming that I might have done along the way.
Mm-hmm.
Okay, so yeah, this is the my PowerPoint presentation. Um, so
We
a little bit
don't
about me.
see it yet. I
Oh, you don't see my screen? Oh,
Yes, we're still on the roast check.
oh, here, let me share. Sorry about that. How about now? Can you see it?
Okay, now we do. Yes.
Okay, yes. So this is my PowerPoint for the ROS2 navigation in 5 days, and um, so a little bit about me. My name is Ben Buley, and I'm a senior at the University of Houston. Uh, I'm majoring in electrical engineering, and my concentration for my major is in signals and controls.
Mm-hmm.
And real quick, there's a picture of me with the SLS rocket a few years ago while I was interning at Boeing in Cape Canaveral. So I thought that was pretty cool.
Yeah, it is.
Um, thank you. So to kind of go over the project objectives a little bit, I kind of went through them demoing it. But so very quickly, the first thing was to generate the map of the environment for the robot. So I kind of mentioned this earlier, but rather than generating a map using the real robot environment,
Yes.
I use the simulated environment. And the reason I did this again was because a lot of the times when I would tap into the robot at different scheduling times, the tracks, obstacles, and things around the map, they changed almost every time, due to other users doing their own projects. So I found that having a baseline map where things remained consistent in the environment and don't change, that was an easy solution for this. But the basic process is almost exactly the same, regardless, in terms of saving the map, and I'll get more into that. But once the map was saved or generated using SLAM, it was then saved, and then I instructed it to localize the robot around the given environment. And this basically means giving the robot the ability to figure out where it is on the saved map in real time. And I used the AMCL node from Nav2 for that. And then once localization was set up and the robot was able to identify its position on the saved map, the next phase was to enable navigation. So throughout this process, I saved the points throughout the map environment to navigate to them, using what it had learned by exploring the map environment in the localization part. Okay. So before the robot can localize or navigate, it first needs a map of its environment, right? So to create this map, I used a cartographer, which is the real-time SLAM system. So what this system does is it allows the robot to kind of build a map while simultaneously giving its own position on the map by using sensor data. So, cartographer, it kind of uses data from the laser scanner and odometry to kind of estimate where it is over time. So as the robot moves, it's continuously updating. In the 2D occupancy grid, which is like the free space, the obstacles, and the unknown areas. So for my project, I launched the cartographer using the project mapping package, what I showed in the beginning.
You got 2 more minutes, Ben.
Oh, okay.
All right.
Sorry about that. I'll keep going. But yeah, so as you can see, the top one is the real map. The bottom one is the simulated map. All right. And then for localization, the next step was giving the robot its ability to figure out where it is on the saved map.
Right.
So to do this, I used AMCL. And you saw I used the particle filter to kind of estimate the robot's pose based on laser scan. So yeah, and as you can see, kind of here is the particle cloud around the robot before I made a full lap, and here is afterwards, meaning that it is localizing in the environment that was given. All right, next is navigation. So with localization set up and the robot able to identify its position on the saved map, it could start navigation. So I use the Nav2 stack, which kind of provides the tools needed for path planning and obstacle avoidance and stuff. So these kind of launched essential components like the planning server, the behavior tree. Like these nodes are kind of working together to make like the desired outcome.
All right.
So as you saw in the demo, I used a 2D goal pose, and I was able to successfully move the robot by telling it where to go, basically.
All right.
And here at the bottom is what happened in real time, kind of a side-by-side display of it moving. I use just a red arrow to define that. And to kind of talk about the save spots, so where I told the robot to navigate to, I kind of went over this mainly in the demo. I used the custom interface. I called it save spots in the project interfaces package.
All right.
To kind of do this. And I can show, I know I don't have a lot of time, but I can go back and show that.
All right.
But then with navigating to the actual spots, you can see that it was successful as well. It was demonstrated in the demo, but the pictures on the right are meant to be viewed from top to bottom. So the top one is in corner 1, then corner 2, and then in pedestrian.
Right. Right.
You can see right here was successfully moving into those. So in conclusion, the map was saved, was successfully created and saved to be able to use for localization and navigation. The robot in the demo, it properly localized itself to the map. It was able to navigate through the environment, and it was able to save the spots as mentioned and move to those spots when requested to. And so yeah.
All right. Very nice presentation, Ben. So we'll get into the questions just quickly to just find out some of the details. So we did see that your robot can accept a pose as a goal to navigate to, right? But in that process of path planning and that process of getting to that goal, there is a lot going on. So in relation to that, I just want to find out, can you explain to me what the difference between like global and local path planning is, right?
So with global path planning here, let me try and find a way to kind of answer that question.
Mm-hmm.
So I guess with localizing, with local path planning,
Mm-hmm.
I would consider that more to be uh, more internally based, rather than focusing on kind of around the map navigation procedures, I guess I would say.
Yeah, yeah.
So yeah, that's kind of how I would say.
Okay, all right. So you are on the right track. So normally with your local path planning, for example, right, it is the let's just say it is that part of the navigation process where you get certain behaviors like the ability for your robot to avoid obstacles, right? So that's the kind of
Exactly.
blanket term of what local path planning is all about. And then global path planning, like it says, it's the one in which your whole map is being considered so that the robot can find a way of actually getting to that point. But the details and the most important bit is on the local path planning um, uh, section of the explanation, that's where you get behaviors like obstacle avoidance. So in relation to behaviors, can you give me the three default behaviors that your robot can exhibit in the process of navigating through the environment?
Yes. So um, that kind of makes me think of behavior trees
You're right.
in that almost, yeah. So um, let me think about how to answer that. So mm, I guess with the behavior trees, like there's different aspects that you can have it define, like if there were recovery kind of behaviors, turn behaviors,
Mm-hmm.
things like that, to basically um, things that the controller would have like control behaviors basically
Yeah,
is one of the things I would say. Yeah,
they're like
things that could
primitive behaviors that the controller would default to in case the robot sees something in front of it, right? So
exactly, yes, that's what I
they should be three of them that you get by default in the with the nav state.
mean. Isn't one of them spin, the other
Yes.
one spin, uh reverse, I believe,
Yep.
or yeah, and then the other one, I'm trying to remember it. Yeah, there's spin, reverse. Um,
It's pretty simple, the other one.
yeah, I'm just trying to remember the name of it. Yeah, it's like spin, reverse, forward.
I think it's stop. I think it's just stop that you're
Yeah,
looking for.
yes,
So
yes, that's it. Yeah, I'm way overthinking it.
when it's
Yes,
really stuck, then it has to stop, right?
yes, exactly.
It's part of what you want your robot to do, just for security purposes. But yeah, all right, Ben.
Yes, that's exactly. Yeah,
Yeah, it's been a nice presentation though. I really loved the slides and also the explanation. So I think let's wrap it up here, and would like to congratulate you for a job well done. All right.
thank you.
All right. So all right, everyone. So this was Ben's presentation. We give him a very warm congratulations, and to all those who would want to try the courses we offer certification on, we highly encourage you to do so, and you can come and give your presentation as well. So until next time, keep